Okay, welcome to a new video. In this video, we shall look at what history of periodic table, periodicity, that means periodic classification of elements. Let us quickly talk about what the history of periodic table. Let us quickly talk on this man, Anthony Lavoisier is known as father of what? Chemistry. Father of modern chemistry. Father of modern chemistry. What did he do, or what was the contribution of this man? What was the contribution of this man to what? To the development of periodic table? Or what did he do to what? To the building up of periodic table? He classified element into the first man that classified element into what? Metal element. He classified element into metal element, non-metal element. He classified element into what? Gases and into what? Earth. That is the contribution of Anthony Lavoisier to what? To periodic table. He only what? Classified element into what? Metal element, non-metal element, gases, and what? Earth. Let's go to another man that we need to look at what he did to periodic table. He's known as what? Wolfgang Duborena. Wolfgang Duborena. Wolfgang Duborena. Johann Wolfgang Duborena. Johann Wolfgang Duborena. And this man used what? Triad method. They call it Duborena triad. What did he say? He says that when you have three elements, X, Y, Z, to get the atomic weight, of Y, you have to add atomic weight of X and Z, then divide by what? 2. That is what? Duborena triad method. That is, to get atomic weight of Y, you have to add the atomic weight of what? X and Y divided by 2. That means atomic weight of the middle element, when you have 3 elements, is obtained when you add the atomic weight of the first element and the third element, then divide by 2. Let us look at some elements that follow Duborena triad method. Duborena triad method that follows Duborena triad method. When you have lithium, sodium, potassium. Lithium is 7, potassium is 23, sodium is 23, potassium is 39. Let's see if this follows Duborena triad method. That means to get the what? Atomic weight of sodium. That means you have to add atomic weight of lithium and potassium divided by 2. Let's see if you are going to get 23. That means 7 plus what? 39 over 2. This one gives what? 46 over 2. That means you have 23. That means this follows Duborena triad method. We have chlorine, bromine, and iodine. We have 35.5, 80, and 127. Let's see if this one follows that method. To get the atomic weight of bromine, that means atomic weight of bromine will be what? Atomic weight of chlorine plus atomic weight of iodine divided by what? 2. Let's see what we get. We get 81.5, which is very close to this. Let's look at another one. If it follows what? Duborena triad method. That means elements in the same group. Let's see another one. Follow what? Duborena triad method. Duborena triad method. When you have calcium 40, strontium 88, and barium 137. Let's see. To get atomic weight of the middle one, strontium, that means you have to add atomic weight of calcium 40 plus atomic weight of barium 137 divided by 2. This one will give you 177 divided by 2 will give you 88.5. That's it, it's very close. He followed that tried method. But he failed. He failed. Not all known elements could not be fixed into our tried method. That is one of the demerits of our Doberena. Let's look at the demerit. The merit of or the failure of Doberena. The failure of Doberena. The failure of Doberena. The merit of Doberena. Doberena. Number one, all unknown element could not be fixed into trials method. Take note of that. Number two, element in the same group do not obey tried method. Elements in the same group do not obey tried method. What are the elements? Let's look at fluorine, chlorine, bromine. Let's look at this. Fluorine is 19. Chlorine is 35.5. Bromine is 80. Let's see if this one, you see this one failed. It failed with this one. Now you should have atomic weight of chlorine. That means I have to add atomic weight of fluorine and what? Bromine, which is 80. Then divide by 2. This one gives 99/2, which will be, if you do 99/2, we have 48.5. Can you see? It doesn't obey. They are in the same group. They do not obey. That means it does. That means it failed. That is one of the failure of our Doberena. These are the merits of Doberena tried method. The merits of Doberena tried method. Take note. Let's go to another man that contributes to what? To periodic table. This one is known as Newland octave law. Newland octave law. He used octave law. Newland octave law. Newland octave law or rule. Newland octave rule. He said that when elements are arranged in increasing order of atomic weight, the eighth element of, let me say, in increasing order of atomic weight, the properties, the physical and chemical properties of the eighth element is the repetition of the first element. When elements are arranged in increasing order of atomic weight, The physical and chemical property of the eighth element is the repetition of the first element. What does it mean by this? Look at this. When I have lithium, sodium, potassium, beryllium, magnesium, calcium, boron, aluminium, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine. Noble gases is not included. That was one of the failure of this man. Noble gases is not included. Let's look at this. It says that when elements are arranged in order of their increasing atomic weight, the physical property of the eighth element is the repetition of the first element. Look at this. This is the first element. Lithium. 1, 2, 3, 4, 5, 6, 7, 8. The eighth element, the physical and chemical property of this sodium is the repetition of what? Of the physical property and chemical property of sodium. That is what Newland octave rule is saying. That the eighth element, the physical and chemical property of the eighth element is the repetition of the what? Of the property of the first element. The first element here is lithium. 1, 2, 3, 4, 5, 6, 7, 8. That means this one they have the same physical and chemical property. If I take sodium as the first element, that means 1, 2, 3, 4, 5, 6, 7, 8. Potassium is the eighth element. We have what? The same chemical and physical property of this. If I take beryllium as the first element, 1, 2, 3, 4, 5, 6, 7, 8. Magnesium is taking what? Chemical property, the same chemical property of what? Beryllium. If I take magnesium as the first element, 1, 2, 3, 4, 5, 6, 7, 8. Calcium, we have the same chemical and physical property as what? Magnesium. If I take boron as the first element, 1, 2, 3, 4, 5, 6, 7, 8. Aluminium will take the same physical and chemical property of boron. But the failure is that the discovery of noble gas and what? The discovery of every element. This law will not work more than element with atomic number of 40, which is calcium. You can't go beyond 40. This discovery of every element like lead, like that means affected this word, this rule. Let us look at the demerits. Demerit. Let's look at the demerit. Let's look at the demerit. I said when elements are arranged in increasing order of atomic weight, the physical and chemical property of the eighth element is the repetition. Please take note, repetition of the first element. Let's look at the demerit. Demerit. Number 1, discovery of noble gases. Demerit of Newland. Demerit. Number 1, of Newland octave. Number 1, discovery of noble gases. When noble gases was discovered, it affected the world, the law. Number 2, discovery of every element. Discovery of every element. Number 3, the octave law could not go beyond element with atomic weight of 40, which is calcium. Could not go beyond element with atomic weight of 40, which is what? Calcium. Take note of that. Let us go toward Dmitri Mendeleev, which is known as father of the periodic table. Is there in your jam? Is there in your paper? Father of the periodic table. Father of the periodic world table. Father of the periodic table. Let's Dimitri Mendeleev. Dimitri Mendeleev. Let's go. Next one. Dimitri Mendeleev. Dimitri Mendeleev. This man gave what we know as old periodic law. Old periodic law. I said that he's known as the father of the periodic table. He's known as the father of the periodic table. Why? Because he classified all the known 63 elements. He put them in periodic table. All the 63 elements, he put them in the periodic table. And he gave the framework of this model periodic table. And he left spaces for undiscovered elements. And he gave the prediction of their chemical properties. He gave the prediction of their chemical properties. That is why he's known as the father of our periodic table. Let us look at the law again. Old periodic law. Take note of this. You have to know this law. Old periodic law. It states that the properties of elements is the periodic function of their atomic weight. Is the periodic function of the atomic weight. That the properties of element in the periodic table is the periodic function of the atomic weight. He arranged all the elements, all the 63 known elements, in order of what? Their atomic weight. In order of increasing of their what? Atomic weight. Take note of that. Take note of that. It gives the word old periodic law. Old periodic law. That means he arranged elements in order of what? Atomic weight. He arranged elements in order of atomic weight. He arranged elements in order of atomic weight. Let us look at that. Let us look at the periodic table of Mendeleev. Let's look at the periodic table of Mendeleev. This is the periodic table of what? Mendeleev. Old periodic table of Mendeleev. Take note of this. Look at this. How many groups? He what? Draw the periodic table based on what? Vertical and horizontal. The horizontal is known as what? Row. That is period. The horizontal, which is row, is known as what? Period. The vertical is known as what? Group, which is what? Column. He arranged the element in increasing order. In what? Row. Then link it up with what? With group, which is what? Column. He arranged element in order of increasing order in what? Row. Then link it up with what? With column, which is what? Group. And when he did that, look at this. In Mendeleev periodic table, let me draw it here because we have some elements here, but I don't want to waste time because of the board, the width of the board, the length or the width of the board. I don't want to write here, but we have some elements here. Take note, we have some elements here. This is old periodic table of Mendeleev. Mendeleev periodic table has what? 8 groups. Take note. I want to give you group. Point 8 groups. The groups, each group is divided into 2. Can you see? This is group 1 divided into 2. Group 2 into 2. Group 3 into 2. Each group is divided into 2. That means we have subgroups. That means we have the main group, and what? Subgroups. The main group is what? The A. Subgroup is what? B. That means in group 1 I have the main group, which is group A. Then the subgroup is what? B. They are group 1. And in group 1, the main group, we have hydrogen, lithium, sodium, potassium, rubidium, calcium. In the 7th one, we have francium, because Mendeleev periodic table has 7 what? Period. 7 period. But I only drew what? 6. And it has what? 8 group. Each group has what? A and B. That is main group and subgroup. Element in main group, Mendeleev periodic table, I repeat, has what? 8 group. Each group has what? Main group and subgroup, which are what? A and B. In the main group, element in the main group have the same valence electron. The same valence electron. Take note. The same valence electron. While element in subgroup have the same properties. This one, element in subgroup have the same properties. Properties. Take note. The same properties. The Mendeleev periodic table has 7 periods. 7 periods. Take note. It has 7 periods. Period is what? The row. That is horizontal arrangement. The group is what? Column. That is vertical arrangement. That is group. It has 8 vertical arrangement. Each vertical arrangement has what? 2 subgroups, which are A and B. Each group has what? A and B, main group and subgroup. Then it has 7 periods. Period is known as what? Row. Another thing you have to know about Mendeleev periodic table. Metals, as you are moving from left to what? Right. From left to right. Metals are at the left. And as you are moving to right, we have what? More metals in the period. Under the period, as you are moving from left to right, that means we have metals from left to right, which is what? Non-metals in the period. Take note, according to Mendeleev periodic table. That means Mendeleev periodic table has 8 groups, and each group has A and B, the main group and the subgroup. Elements in the same group have the same valence electron, while elements in subgroup, they have the same properties. Then the 7th period, as we are moving from left to right across the period is full. We have metal at the left, then non-metal at the what? Right. As we are moving from left to right, take note of that. That is Mendeleev periodic table. Let us look at what the merit of Mendeleev periodic table. The merit. If you look at this table, can you see Mendeleev put hydrogen in group 1. You also, if I draw the complete periodic table of Mendeleev, also put hydrogen in group 7. That means Mendeleev has no position for what? Hydrogen. He put it in group 1 because hydrogen exhibits the characteristic of group 1. He also put it in group 7 because he exhibits the characteristic of group 7. That means that is one of the demerits of Mendeleev. That means he has no position for what? Hydrogen. But let us continue. Let us look at the demerit and the merit. Let us start with the merit. The merit of Mendeleev periodic table. Mendeleev periodic table. Number 1, he classified or he arranged all the known 63 elements. Merit of Mendeleev periodic table. Merit of Mendeleev. Number 1, he arranged all the 63 known elements in periodic table. Not like Dr. Meyer only arranged 28 elements. They work independently. differently. Lothar Meyer and Mendeleev, they work independently, differently. This one, Lothar Meyer, Lothar Meyer only arranged 28 elements in the periodic table. Only 28. But Mendeleev arranged all the 63 known elements then in the periodic table. He arranged all the old 63 elements in the periodic table. But Lothar Meyer only arranged 28. Let's continue. Another one, the property of the element is in the increasing order of atomic weight. Properties of element are in increasing order of atomic weight. Increasing order of atomic weight. That is the second one. The property of the element are in increasing order of atomic weight. The property of the element are increasing order of the atomic weight. Number 3. Elect spaces. If you look at the periodic table, when I do it, you will see some spaces. Elect spaces for undiscovered element. He left spaces for undiscovered element, or he left gaps for undiscovered element. Number 4, he predicted the properties of undiscovered element. He predicted the properties of undiscovered element. Take note of that. Those are the merit of Mendeleev periodic table. Let us look at the demerits. You can pause the video and let us look at the demerits. Are we set? Let me know. One of the demerits. He grouped the similar elements that are not the same. He grouped them together. He grouped the similar elements. Number 1, he grouped these similar elements. For example, we are in group 1, which are A and B. He grouped sodium, lithium, sodium, potassium in group A, and now group 1, copper and silver in B. Two of them, he said they are in group 1. He grouped the similar element. Mendeleev grouped the similar element. He grouped the similar element. Number two, separation. We are looking at demerit. Please, demerit of Mendeleev. Demerit of Mendeleev periodic table. Number 2, it separates similar elements. Separation of a similar element. Number 3, no position for isotopes. He has no position for isotopes. Mendeleev has no position for isotope. It's not like today that in the modern periodic table, isotope of an element are in the same group. Then he has no position for isotope. He has no position for isotope. He has no position. Number 4, he has no position. No position. He has no position. No position for hydrogen. He has no specific position for hydrogen. Mendeleev has no specific position for hydrogen. In that Mendeleev periodic table, old periodic table, he put hydrogen in group 1, which is group 1A. Then he put it in what? Group 7 again. He has no specific position for what? For hydrogen. Please let us move. Let us look at the last man that work on what? The periodic table we are using now. That means what? Henry Moseley. Henry Moseley. Henry Moseley. Henry Moseley. Henry Moseley. Moseley. Henry. Mostly Henry used what? X-ray experiment. He used X-ray experiment. He used X-ray experiment to discover when he wanted to hit what? A metal with an electron. And he used X-ray in what? Studying that. And he discovered so many things. And in its periodic table, he arranged elements in increasing order of atomic number, increasing order of atomic number. When he performed the experiment, he discovered that square root of what? Frequency is directly proportional to atomic number of element. Take note of that. Henry discovered that square root of frequency is directly proportional to what? Atomic number of what? Of element. He now concluded that elements should be arranged in increasing order of their what? Atomic number. That the properties of element should be in increasing order of their atomic number. It now concluded that the properties of element is in increasing order of atomic number. Not like Mendeleev that arranged elements, the property of elements in increasing order of atomic weight or atomic mass. This one is said that the property of elements should be in increasing order of their atomic number, not atomic weight. In our day world, the modern periodic law. Let us look at law. The modern periodic law. The modern periodic law by Henry Moseley. Modern periodic law. Modern periodic law. It states that the properties of elements is the periodic function of their atomic number. Take note. The old law is what? Atomic weight. The old law is atomic weight. But modern periodic law is said that the property of element is the periodic function of their atomic what? Number. The properties of element is the periodic function of their atomic number. Mostly Henry gave that law, model periodic law. Then let us look at the new periodic table.